material forward onto the platform so that the students can view what I'm going to teach today. Okay, so I have to click on the button here, okay, to locate the material, upload the presentation. Okay, upload the presentation, upload this presentation. I click on browse for the file. I click on browse for the file. I click on browse for the file. I locate it. My file folder is already on the desktop. It's already on the desktop. Okay, I'm already there. I'm already there. Yes. Now this is the file I'm locating. I'm already captured. I click on upload. Okay, I click on upload. Then immediately it will be displayed. Okay, there you are. Now the notes are already there. Okay, the file has already been captured. So now meaning that the students on the other side, they are all seeing what is going on. Okay, yes, let me test one of the students to find out whether they are viewing the file I've displayed on the screen. Okay, Kaira Daniel, do you see the notes on the screen? Can you speak, Kaira? Kaira Daniel, do you see the notes on the screen? Do you see the notes on the screen?
Yes, the notes are on.
They are on. Okay, what is displayed on the screen? What is the topic? Josephine, are you there? Josephine Nama, yes. What is the topic on the screen?
Is population and sampling.
Population and sampling. Well, perfect, wonderful. Okay, yes, we are now looking at population and sampling. Okay, we can even zoom yes, to enlarge it. Okay, so that the students can view it very well. Okay, that is it. Okay, that's population and sampling. Now that you have seen this is my class, okay, the students are out there, they are displayed on this other side when the notes are here. Okay, now this is their whiteboard, okay, which they are going to see. Now those are already these notes which are already embedded within the system. I developed the material for the students to view. But on this side, there are some of the calculations that we are going to see, where with the calculations, I cannot just mere display the notes. I have to do it practically here on the whiteboard as the students are following what I'm doing. Okay. So at the end of the day, in case there is any student who may want to ask a question, the student can use a chat room. There are two categories in this class. There are students who entered by using a microphone. Those ones can even talk, like the way how I've pointed out one Kaira could entered with a microphone, and Josephine Namara also entered with a microphone. That one can even talk to me direct. Now for students who did not enter by microphone, the class by microphone, but only listening, for them, they can use the chat room here. Okay, they can type in the chat room. Students who entered without a microphone, can you type and say, yes, sir? Type in the chat room and say, yes, sir. Okay. Yes, they are typing. Yes, Joan Tumusime has typed yes, sir, meaning that they are actually following what I'm doing, okay, and what I'm delivering. Okay, so now my class is now set for learning to take place. Okay. Then after that, yes, I also have to capture their attendance. Yes, those who attended my class, because I don't want students to dodge. Okay, so when I'm to capture my attendance, I'll come and click on this wheel. Okay, I click on this wheel and say save the names. Okay, save the names. So the system has already captured the attendance, okay, and all are here. Now that's my attendance, classroom attendance. I've seen that now the students who are present in this lecture, I myself, Chagulanyi is captured there, Chagulanyi Ronald is captured there, Namara Josephine is there, Narubega Annette is there, Narunkuma Winfred is there. That is my attendance. I will save it. I can even print and put on file. Okay? Those are the ones who attended this class on the 19th of October 2021 at exactly 1 p.m. 42 minutes. Okay? That's when the attendance was captured. The system has given me that record. I'm going to save on my computer. I can even print it out and put on file. Okay? So now after that, now my class, I've already captured that. I have to also to click on recording, start recording. The lecture has to be recorded. I click on start recording, then I say yes. Okay, now whatever I'm going to deliver today is now being recorded by the system. It is now being recorded by the system. Now let us come to the lecture. Now students, you are seeing population and sampling. Okay, I'm going to put on my camera so that you can see me. Okay, so that you can see me. Okay, so that you can see me. Okay, I'm putting on my webcam. Yes, I put on my webcam. I have to allow it first so that it can view me. Yes, I allow it first. Yes, the camera has come. Now it has tested that I'm already there. It can view me. I can be viewed very well. Now I'm going to share the web camera by clicking on start sharing. Because I've already tested here, it can capture my photo. Okay? Okay. Then I start sharing so that now the students can view me. Okay? Students, can you view the whiteboard? Okay? You can say yes in the chat room or you can speak out. Okay? Can you see on the whiteboard? Yes, I position my laptop so that you can see on the whiteboard?
Yes.
Yes. What is on the whiteboard? What can you see on the whiteboard? Which word is there?
I'm seeing population.
Population. Perfect. So which means that now the students can ably see what I'm going to do. Okay? Yes, students, we are now looking at population and sampling. Okay? Yes, one of the most ingredient parts when we are doing a lecture, or sorry, when we are writing our research, we always talk about population in research methodology. Okay? So what you are seeing there is the population. Okay? Now the people that are involved in this research, of which are going to benefit, okay, from the study conducted, is what we call the population. It's the whole census, okay, of the people or the players in this research, involving the people who will answer our questionnaire, if we are going to use our questionnaire, and also the people who are going to be the beneficiaries of this research. So the entire census is the population. But because of the time factor, we cannot reach out to all those people in the study. So we do need to take a sample. A sample is a small portion representing the entire population. It is the representation of the entire population. And that's what we call population and sampling. Okay. So now, when you are looking at sampling, okay? When we are looking at sampling, the diagram which you are seeing there, displayed on the screen, it has got 3 layers, okay? Students, you must be very careful because I'm going to pose a question after demonstrating this, okay? To test whether you are following, okay? So we have got 3 layers, okay? There is the inner, there is the middle layer, and the outer layer, okay? So the outer layer here, I'm baptizing it the name the target, okay? It is the target population. It is the target population. It is the whole census, okay, of the people who are supposed to be part of the study, okay? Then the inside layer here, we are going to call it sampled, okay? It is called sampled population. It is called sampled population. And then the inner layer is called the sample, okay? It's called the sample. Now it comes like this, okay? That whatever study you conduct, okay? Whatever study you conduct, there is always what we call the target population. In most cases, some of these people are too hard to get at one time T. Okay, the target population. It is like, for example, if I come to Mutesa to conduct a study, okay, in the Faculty of Business and Management, I may be interested in getting all the students in the Faculty of Business and Management. But in most cases, these students may not turn up at that time when I come. The students whom I happen to meet or to find at that time T are the ones we call sampled population. It's the inner layer. So it is from those students that I managed to meet that a sample is drawn. Are we together? That a sample is drawn. So meaning that the information that I'm going to collect from this sample will it will be a true representative of the target population, even those who never knew that I turned up today to collect data. Are we together? So what does that mean? From this diagram, the lessons we learn from the diagram is that when you collect a sample, take the number which is large enough, because it is going to represent the views that you are going to collect will represent the target population, where some members may not even know that a study was conducted. Are we together? So take a sample which is large enough. This is the lesson we learn from this diagram. Okay? So now from that notion, okay, of getting the required sample which is large enough, takes us to use of formulas, okay? To use of formulas to calculate first sample. So let me take you to the use of formulas to adopt one formula, and then we see how do we compute for a sample that we are going to be to use in our research. Okay, so we go ahead. Okay, we go ahead. So we identify a formula. Okay, a formula. Okay, a formula for computing. Okay, formula for calculating a sample. Okay, for calculating a sample. Okay, now I'm going to add this. There are so many formulas, okay, ways of getting a sample, but in this case I'm going to use Sloveni's formula. I'm going to use Sloveni's formula, okay, from Sloveni's formula, which says that to get a smaller sample n, we get capital N over 1 plus capital N in bracket E squared. E squared, meaning that the capital N you see there is the population. The capital N is the population, okay, which was the target population on our diagram. Okay, so now I can still also extend so that you can see on the screen what I'm trying to demonstrate. That's where I am. Okay, then the smaller n is the sample that we are looking for. Is the sample that we are looking for. And then the one here is that whatever we do in research is supposed to be 100%. Okay? It's supposed to be 100%. 100% in statistical terminology is represented by 1. Okay? Then capital N is the population still coming in. The E you are seeing there is the margin. Okay? Is the margin of error. Okay, is the margin of error. Is the margin of error. Why margin of error? That in research and as we are computing for the sample, we must provide for error terms. That whatever we do, it may not be 100% as represented by 1. Okay, so whatever we do, we also provide for error terms. That as I was collecting the sample, I also got some people or respondents who were not even knowledgeable about the subject matter, but they also answered the questions. That's why we are taking a sample which is large enough to minimize the error. Okay, and margin of error is internationally recognized as 5%. Okay, as 5%, meaning that whatever we do is 95%. The 5% is margin of error. So this one can be translated into 0.05. Okay, the 5%, if you get 5 and divide by 100, you get 0.05. Okay, so that is population using Slovenia's formula. At the end of the day, we are also going to test ourselves with Slovenia's formula to see whether we are right, okay? We shall test using Morgan tables, which are already available on the internet. Okay, we shall go into that. But let us first pick an example and then we see how do we compute for our sample. Okay, so this is the formula that we are going to use. Let me rub it. Okay, so now assume example. Okay, example. Assume the population n is equal to 100. Okay, the population n is equal to 100. Then they ask you, use Slovenia's formula to compute for the sample size. Okay, we are going to use Slovenia's formula to compute. To compute for the sample size. To compute for the sample size. Okay? To compute for the sample size. Then this is how we do it. Okay? We shall say that small n is the sample that we are looking for, is equal to 100 over 1 plus 100 in bracket 0.05 but squared, following the Slovenia's formula that we gave us, that n is equal to capital N over 1 plus capital N in bracket E squared. I've replaced everything there with the figures, okay? So this is what I'm going to compute. Then I'll get my calculator, I'll calculate, I know that, I have to first begin with bracket first. I always use the body mass principle, bracket first, okay? So bracket first, I'll begin with this one, the margin of error, which is 0.05 squared. That one will give us 0.0025, okay? When I square that. Okay, so I will multiply that 0.0025 with 100 because I'm going to begin with the denominator. The numerator is okay. It's just 100. So I have to multiply this 0.0025 with 100 to get 0.25. Okay, it gives me 0.25. This one I will add on 1 because I'm adding on 1 plus 1 to get 100 over 1.25. Okay, that's what I'm going to get at the end of the day. So I will divide 100 by 1.25 to get the sample size. Okay, so at the end of the day, yes, I can use the calculator here. Let me borrow a calculator from the system here. That is, if I get 100 and I divide by 1.25, what do I get? I get 80. So the sample is 80. So now 80 members, whom we call in research respondents, will participate in this study. Okay? So that's what we have got at the end of the day. Then, someone will say, how do I test that really it is the 80? Let us look at Morgan tables. Let me take you to the Morgan tables. The small s shows the sample, meaning that when the population is this, the sample is supposed to be that. Okay? So let us look at 100. Can you locate 100 on the table? What is there? Yes, Josephine. What is the population size as per Morgan tables? At 100, population 100. You can talk?
It's 80.
It is 80. Okay, perfectly. We have proved with our Slovenia's formula with the Morgan tables which are available on the internet. Meaning that whatever we are doing actually is right. Okay? So this is what we call computing for the sample size using Slovenia's formula. Okay? Why? We don't want students or researchers to abuse sampling. Sampling is not just thinking of a figure. You must have a basis at which you used, okay, to arrive at that figure which you can ably defend. Okay? Yes. And so that is what we call population and sampling. Now students, let me test to see whether you have learned what I've taught you today. Okay? Yes, testing now. I'm going to pose a question. Okay? I'm going to pose a question. Okay? What was the purpose of the small sample we computed? What was the purpose as per the diagram that was displayed? What was the purpose of computing for the small sample? Anyone who can respond to that question? What was the purpose? What was the major purpose? I can even still type the question in the chat room, okay? What was the purpose? Sample. Okay. As per the diagram. Okay. The diagram. Now that we have seen that students can even respond, very well on the system. Yes, after undergoing the lecture, they have been in position to tell us the samples, the purpose of the letter E in the formula, that is the margin of error that we have to provide for the error terms. And also the purpose of S is that the smaller sample represents the views of the entire, or the true picture of the entire population. Actually, it has given us a lesson that students with online, they are comfortable, they can learn even when they are away from the university. They can be at home. We have seen these students are aware, but they were in position to follow, okay, the lecture as if the lecture was delivered face to face, okay? Meaning that with online teaching, we cannot say that learning cannot take place because students are away. So it is a new way of delivering the knowledge, delivering the matter, which we are calling upon all students to adopt. Okay, the most important thing is that students must get the good gadget that can access the system. So they must have a smartphone, or if not a smartphone, a good laptop, or if not a laptop, a desktop. But where they have a desktop computer, they must have the gadgets. Either they must have the headphone together with a microphone, so that they can learn very well on the system, okay, without coming here to the university. So I extend warm greetings to you all, those who have attended my presentation. Yes, and this is Faculty of Business and Management. I remain as Dr. Ronald Chaguranyi. Goodbye.